When people hear the word vacuum, they imagine nothing at all. They picture a dark, endless void, completely empty. But what if I told you that space itself is buzzing with hidden activity? The emptiness out there is only an illusion. Even when we strip away stars, planets, and dust, something amazing is happening in the darkness. Think of outer space as the world's biggest, blackest, quietest room. But even in this room, things are not as quiet as they seem. The universe is full of secrets, and one of the biggest is that what we call nothing is actually something. This surprising truth changes the way we see space itself. Scientists used to believe a vacuum meant the total absence of matter. No atoms, no molecules, nothing at all. But they were in for an astonishing discovery. They found out that even the emptiest places are not truly empty. The idea that empty space is alive with invisible activity grabs our attention. It challenges what we thought we knew, and it invites us to look deeper into the universe's secrets. Let's start at the beginning. A vacuum is a space with no matter in it. You might have seen astronauts floating in the vacuum of space, far from Earth. Even inside science labs, machines suck air out of containers to make a vacuum. For a long time, people thought a perfect vacuum meant total emptiness. But nature doesn't like a true vacuum. At the tiniest scales, strange things happen. This is where quantum physics comes in. Quantum physics shows us the universe behaves in ways we can't see with our eyes. It tells us that even in a vacuum, energy is always present. This hidden energy causes space to shimmer with activity. The vacuum is not a silent, empty box. Instead, it's more like a restless sea. At the smallest level, tiny waves of energy ripple through it all the time. This restless, invisible motion is called a quantum fluctuation. It means space is never truly still. Something is always happening, even when it looks empty to us. So what are quantum fluctuations? Imagine the universe as a giant stage. On this stage, particles can sneak in and out, almost like ghosts. These particles appear and disappear so quickly that we call them virtual particles. They are not real in the way atoms are, but they still have effects we can measure. Virtual particles pop into existence in pairs, a particle and its opposite called an antiparticle. They live for only a split second before they cancel each other out and vanish again. This happens everywhere, all the time, even in what we call empty space. Picture a busy playground where children run in and out playing tag. The playground looks empty from far away, but up close there's a flurry of quick hidden movements. That's what is happening in a quantum vacuum. All these tiny comings and goings add up to a lively, bustling space. Scientists can even measure the effects of these virtual particles. For example, they help explain why some atoms behave the way they do. It's proof that the vacuum is not just empty. It's alive with invisible action. Many people are surprised to learn that space is never truly empty. This discovery changes everything. It means the universe is always active, always full of hidden wonders. The vacuum is like a canvas, filled with invisible brushstrokes of energy and motion. Quantum fluctuations might seem tiny, but their effects are huge. They help scientists explain things like why stars shine or why black holes slowly fade away. Some even believe that the universe itself began as a quantum fluctuation, proof that nothing can turn into something on a cosmic scale. This idea makes space far more interesting than we ever imagined. It's not a cold, empty wasteland. It's a living, dynamic place full of surprises. The universe is more alive, more creative, and more mysterious than we ever thought. The more we learn about quantum fluctuations, the more we understand our place in the cosmos. Space is not boring or empty. It's the stage for the greatest show in the universe, and we're all part of its story.